Okay, so a spotlight on the ground shines on a wall 10 meters away. So I'm going to put the spotlight right here, and 10 meters away I've got this wall. A man 2 meters tall walks from the spotlight. Okay, so this is, oh, I don't know how tall the wall is. This man is 2 meters tall, and he's walking that way. He's walking towards the wall, and he's got this speed of 1.2 meters per second. The question is, how fast is the shadow on the wall decreasing when he is 3 meters from the wall? Okay, so just a picture of what's happening. Then at this point, this would be the height of his shadow. If he moves further, closer to the wall, and let's just put this man right over here, then his shadow is going to look like that, right here. So you can see that the shadow decreases. Okay, so let's get some variables here. Let's let x equal the distance, and you have to decide which way you're going to be measuring the distance. Are you going to measure the distance from the spotlight to the man, or from the man to the wall? I was measuring the distance between the man and the wall. So let x equal the distance from man to wall, and y equal the height of his shadow. Okay, so y would be right here, and x, the distance from the wall to the man, would be here, or at this point here. Note that the whole distance from the spotlight to the wall is always 10. Okay, then what's the given in the question? So what's given in our question is the rate at which this man is walking. He's walking at a speed of 1.2 meters per second. That means that the change in x with respect to time is 1.2 meters per second, and I'm going to make it negative because it's getting smaller. It's the distance between the man and the wall, and that distance decreases. If I defined it the other way, then I would have to make it positive because it would be getting bigger. Okay, what am I trying to find? I'm trying to find how fast the shadow is decreasing. That is, I'm looking for dy by dt at this moment when he is 3 meters from the wall. That is, what is the change in y with respect to time at the moment x is 3? So you see why I said x is the distance from the man to the wall? Because that's the distance I was given when he is 3 meters from the wall. If it said when he's 3 meters from the spotlight, then I would have let x equal the distance from the spotlight to the man. Okay, so just really define those variables, because you can get yourself very mixed up if you're not clear about which distance you're measuring. Okay, so if I'm trying to find dy by dt, I know dx by dt. Can you see some similar triangles in there to help you find a relationship? That is, if I look at this triangle here, and I look at, hold on, that's not the one I wanted to look at. I wanted to look at this triangle here, and this triangle right here. Can you see that? Of course we can see that those have to be similar triangles. Okay, so the one that I highlighted in blue, this blue triangle, we know a little bit about it. We know the base is 10, and we've labeled the height to be y. This one in orange, we know a few things about that one. Let's label them. We know the height of this one. What is it? 2, the height of the man. Do we know the length of this? Do we know the length of that? We don't know it exactly. We knew it as a variable. It's not 10. The whole thing is 10. This part's x. So this part in here would be 10 minus x. So those two triangles are similar triangles. Set up a relationship between them. So two similar triangles, I could say the height is to the height what the base is to the base. That is y is to 2 what 10 is to 10 minus x. And probably this would be a little bit easier to work with if I wrote it this way. Multiply both sides by 2, and I get y is equal to 20 over 10 minus x. Or y is equal to 20 times 10 minus x to the minus 1. Since I'm trying to find dy by dt, we're going to differentiate both sides with respect to time. So the derivative of y with respect to time will equal the derivative of this side with respect to time. Pull the constant out in front. The derivative with respect to time would be negative 1 times 10 minus x to the negative 2. Chain rule times the derivative of the inside function, negative 1 dx by dt. Okay, so simplifying, this is going to be a positive, and I've got 20 over 10 minus x squared dx by dt. So dy by dt is equal to positive 20 over 10 minus x all squared dx by dt. So plug in what you know. We know dx by dt. We know x. Hey, wait a minute. We know x. We know dx by dt. We're trying to find dy by dt. Okay, so here we go. We've got 20 divided by 10 minus 3 all squared multiplied by negative 1.2. So, and why can't I write this properly? 10 minus 3. So 10 minus 3, 7 squared, I get 20 over 49 times negative 1.2 is giving me approximately negative 4.9, and that would be measured in meters per second. So the shadow is decreasing at a rate of 4.9 meters per second when the man is 3 meters from the wall.